relative velocity. This is all about understanding that movement of any vector in any direction is dependent or relies on who's observing it. And if you're moving, or if your reference point is different to someone else's reference point, then the relative velocity will change. We're going to look at some examples, but this is the rule. If you're talking about the velocity of B relative to A, then you start with velocity B and you minus velocity A. And we're going to look at some examples right now.
I'm vector A. I'm vector B. I'm vector C.
So for the first situation, we have vector A moving in this direction, and we have vector B also moving in the same direction. And these vectors actually are twins, so they have the same magnitude of 10 in the direction down the ramp. So if we want to look at the direction of vector A and direction B, they're the same and the magnitude is the same. Let's think about now the velocity of vector A relative to vector B is A minus B. So vector A minus vector B, which is just adding it in the negative direction, 10 equals 0. So we'll give it some units now. So each of these vectors relative to each other is moving at 0 meters per second. In other words, they're moving along together. In this situation, we have vector A moving in 10 down and vector B moving at 10 up. So, same thing. A, B. The velocity of A relative to B is the same thing. A minus B. But in this situation we have 10 minus a minus. And when we minus a minus it becomes a positive. So if we were going to add the nose to tail, and the resultant answer is 20. So what we've done here is minus a negative vector, which two minuses becomes a positive, change the direction, and then we get double the answer. In this situation, we have vector C moving at 7, and we have vector B moving at 10. So if we want to know the velocity of B to C, we just minus them. So B minus BC equals 10 minus 7, same direction, and the answer 3 meters per second this direction up the hill. Now in this last situation, we're introducing a different surface. So we have the travelator moving down, let's call it at 5. Okay. Now relative to a stationary observer, each of those vectors now has this So to you or I standing stationary, that's the answer vector. Each of them now has a relative velocity compared to a stationary observer is 15 or 12. However, to them, travelling, we go back to the original scenario of just their velocities relative to each other. So velocity really does depend on the observer or the reference frame.